Now let's start studying orbitals systematically and what is required in AS level. Now you've probably gotten the concept that an orbital is simply a region of space where an electron might be located. And what does an electron look like? We don't know. It's either a wave, it behaves, sometimes it behaves as a wave, and sometimes it's behaving as a particle. So it might be existing in that region. So let's start off with the first orbital. Remember one thing, I'll start writing down points. Each orbital contains a maximum of 2 electrons. So this is an important point, that each orbital is going to have a maximum of 2 electrons in it. Let's start off with the first orbital. The first orbital is the s orbital. And we've already discussed that s orbital is, the shape of the orbital is spherical. So if you have a nucleus in the center, the shape of an s orbital is going to be, it's going to be a region of space which is going to cover a spherical region around the nucleus, and an electron, if it's present in the s orbital, might be existing in this region. Similarly, let's move on to the other orbital, which is the p orbital. Now the problem with the p orbital is that the shape of a p orbital is double shaped. We've already discussed that if you look at a p orbital, and if there's a nucleus right in the center, then a p orbital would be, there would be a region of space on one side of the nucleus where an electron might exist, and on the other side of the nucleus. So this entire thing is a p orbital. So the electron might be existing, if it's existing in the p orbital, it might be existing in this region, in this entire region. So the shape of a p orbital is double shaped. But what's more important to know is that when we talk about a p orbital, there are actually three orbitals that we are talking about. One is the px orbital. It lies on the x-axis. Then you have the py orbital, which lies on the y-axis, and you have the pz orbital. So the important thing to remember is that there are three orbitals that we are talking about whenever we mention the word p orbital. So in total, the p orbital is going to have how many electrons? Each orbital has 2 electrons each. There'll be 2 electrons in the px orbital. There'll be 2 electrons. I'm talking about the maximum number of electrons that can that an orbital can hold, and there would be 2 electrons in the pz orbital. So that would give you a total of 6 electrons. Now let me draw how a p orbital with the px, py, and pz orbital would look like. Let's say this here, I'm drawing a three-dimensional diagram. So let's say this is the x-axis, this over here is the y-axis, and this dotted line represents the axis coming out of the page and going into the page. So you have the px orbital would be residing on the y-axis. This center point over here, which I'm pointing to, is the nucleus. So an electron might be residing in this entire region if it's in the py orbital. Similarly, you have the px orbital. So px orbital would be lying on the x-axis. So this is the region which we are going to call the px orbital. This is the region which we are going to call the py region. And then you're going to have the pz orbital. This was the z-axis over here. So this here is the pz orbital. So you have these three orbitals, and this entire thing is called the p orbital. There are going to be 6 electrons. There would be 2 electrons in the py, maximum of 2 electrons. There will be maximum of 2 electrons in the px orbital, and there would be maximum of 2 electrons in the pz orbital. So you have three different orbitals when you talk about the p orbital. So this would be the shape of a typical p orbital. Now, when we talk about AS chemistry, d orbitals are generally not in our syllabus. The only thing that you need to know about d orbitals is, let's move on to d orbitals. The only important thing that you need to know in AS chemistry is that d orbitals consist that there are five different d orbitals. There is dxy, there is dxz, there is dyz, there is and there are two more. There's dx square minus y square, and there's another orbital called dz squared. Now you have these five orbitals. I'm not going to go into the shape because that's part of A2 chemistry. But if you look, or maybe I should draw the shapes of these orbitals as well. So I'll give you an idea of a dxy orbital. So this here is my x and y axis, whereas this over here is the z-axis. Now a dxy orbital is like it's like a flower with four lobes. There would be four different regions around the nucleus where an electron might be existing. So there would a maximum of 2 electrons can accommodate this region. So this region looks like this, and there would be a maximum of 2 electrons residing in this region. And since it's a dxy orbital, dxy means that the orbital would be existing, that this flower shape would be existing between the lobes of the flower would be existing between the x and y axis, and nothing would be on the z axis. Similarly, dxz would have a similar shape, except that the lobes of this flower would be existing between the x and z axis. Similarly, yz would be the lobes of this flower would be existing between the y and z. Then you have so these three are basically quite similar. They're just oriented differently in the three-dimensional space. So there are three orbitals with exactly the same shape. dx square minus y square, that's also having the same shape, except that the lobes of this flower would be existing on the x and y axis. So this would be dx square minus y square, and that would also have a maximum of 2 electrons in it. We've already discussed the dz square orbital. That has a different shape. It's not flower shaped. It's slightly different, and the shape would be that it's lying on the z-axis. This is the x, this is the y, and this is the z-axis. You have one lobe on top of the nucleus and another lobe below the nucleus. Plus, there's going to be a donut-shaped ring-like structure around where the electron might exist as well. So this is the shape of a dz square. This is a region where a maximum of 2 electrons would be existing as well. So in total, there are 5d orbitals. So the total number of electrons that can exist in 5d orbitals would be 10 electrons. So a maximum of 10 electrons can accommodate the d orbitals. Anything less than 10 can be accommodated. Anything more than 10 cannot be accommodated. So I'll just go through and review the shapes of the orbitals or the regions which are going to hold electrons. You have an s orbital, which is spherical, and the maximum amount of electrons, there's only one s orbital. The maximum amount of electrons that it can hold is 2 electrons. Similarly, you have the p orbital, which is basically composed of three separate p orbitals. One is the px, py, and pz. Px lies on the x-axis, py lies on the y-axis, and pz is lying on the z-axis. And lastly, you have the d orbital, which has five separate d orbitals. You don't need to even remember the name. Each d orbital is going to hold 2 electrons. The shapes are not important, at least in AS. A maximum of 10 electrons can be accommodated in all the 5d orbitals. And lastly, you have an f orbital, but It's better that we avoid the F orbital because in AS hardly there's a very high probability no question is going to come that's going to discuss the F orbital.